Thanks everyone for having me here. The topic itself is explanatory about automated armor. Of course, we're going to learn a lot about automation. Automation specific with the CICD. You can consider any CICD as in GitHub, GitLab, or is there if it is there in any as such, which allows you to do the CICD continuous integration, continuous development thing. And yeah, before I proceed with the further, I'd like to thank Visarian for creating such a good, insightful talk for across the globe. And all the credit goes to that legend guy. And it's not the first time I'm giving talk for Mystico. The community Mystico is since 2017, I believe. And since that 2018, the talk every year or every year talk is being scheduled from him. So yeah, all credit again goes to Visarian. Thanks Visarian for having me here, and thanks everyone for being a good listener. And I would expect you to continuous being here, and probably this would be our last talk as I have scheduled the last time. And I'm pre-recording this just to save my own time in case of any unavailability issues, things like that. And yeah, also, I'd like to thank all the sponsors, and of course, I'm one of them. That's being said, let's move further with a little introduction about me. So, yeah, myself, Rikun Sindwar. You can also search across with the Robensive word, and you will find yourself redirecting to me as well. So, Robensive is one of the name that I designed for myself or my community. If in the future you find a particular company name Robensive, expect I would be the owner. Red and purple team is what my expertise, what I like, why I choose in purple team out of the red team. Red team in which we have to be very limited. We cannot expand ourselves with such things. Whereas purple team is something which is continuous, where we perform certain attacks, we try to defend, or we of course will not going to defend on ourselves. We'll try let the blue team help to defend those attacks, and we try to maturize our attack in order to uh, do our own development, and it's more towards research based role, and that's the reason I chosen to go with the purple team. Of course, I do red teaming engagement, I do some researches, I do have certain CVEs, a lot of things. I'm the senior consultant currently working with Ernst& Young, which is EY so called, and EY India specific. Cybersecurity trainer is what I partially, or I would say as a freelance, I still do for the corporate, for the individual, in terms of a training, providing a technical training, not the non-technical thing. And if you come to me and asking for such training, I might not be the suitable. But if you want to get some hardcore offensive side training, then yeah, I would be the one that you can go for. I've also developed a couple of tools. There are some more, but yeah, I've just highlighted three. First one is MS SQL Attacker, which I created when I was doing my OSEP certificate. That tool allows you to attack MS SQL and linked MS SQL servers in various different methodologies. Proxy Checker is one of the tools which I designed for creating proxy DLLs for the known DLLs or the DLL that you can pass on. What it will gonna do, it will take a shell code, it will just take another argument as a DLL, actual DLL you want to be proxied, and it will do the needful. It will create a proxy DLL which you can replace, or which you can put it in your whatever the vulnerable location for the DLL hijacking, and that should be enough. Task Ninja is one of the great, I would say, one of the best tool that I have designed so far. It is purely, I can say, taken some ideas from Trickest. If you have heard Trickest, then yeah, I would like to give some credit to them because they have the raw core idea around. What it does basically, Task Ninja helps you to automate certain workflows which you do it on your regular basis. It can be for external, it can be for internal, and it uses Docker. So everything, there will be no issue with the let's say configuration issues or deployment issues or anything as such. You can create your own containers, including whatever the tool you would like to have, and you can use Task Ninja to create a workflow. That workflow will going to execute it within the Docker, and the result can be achieved across. What do I mean by across? As let's say you have a plan to have certain different tasks to be executed. First task output, you want to pass it to the second task. Then yeah, Task Ninja is something that can achieve that. You can also have your own script tool or whatever you want to be ported inside the Docker. And yeah, there is a lot, and I've already created a couple of videos which you can navigate by just going through um, the official readme file for the same. That's the whole short introduction for me, and let's proceed with the further. Okay, so what are the things that you would be or you will going to be learning by the next hour, or all about the next hour? Basics, you will going to get a basic hands-on what are the CICD and the basic architecture that I would like you to just aware. Of course, we are not a developer who's going to learn bits and pieces, but some of the core or some of the important topics that I would like you to know, I'll be covering here. We're going to learn all about attack surface management, what exactly a particular attack surface management it is. I have already been working since almost like a year now for doing some automation across attack surface management. I've done a good stuff here. So in case you're stuck somewhere in the future, just reach out to me. I'll be happy to help you out. Understanding the issues and its solution with the CI/CD, different issues that you might gonna face. What would be the solution for that? Making a basic workflow with the GitHub Actions, make some offensive workflow in terms of, let's say, attack surface management, so-called ASM. And yeah, I'll try to keep it everything as practical. Of course, the practical part I have pre-recorded just to save everyone's time, but it will not going to be differ than someone is actually performing certain things. By the end of the talk, I would expecting you to be a CI/CD automation hacker. That being said, let's move towards the next slide. Okay, let's talk a little bit about what is CI, what is CD, and some use cases along with some components. So CI, it says continuous integration. The term itself says continuous integration. Means you want to integrate something again and again and again and again. What exactly it does? It does automate code integration, merges the code changes frequently into the shared repository, early issue detection. It identifies particular bugs if there is any, if you have already designed such thing. Do not worry about this. I'll explain each and everything in detail. What the CD tells you that it's a continuous development. What it does, it automatically creates a release for your particular product. So let's take it with an example. Let's say you have created particular tool, script, software, and whatnot. What the CI will going to do, let's say you have created some checklist, that checklist will going to be followed by the CI. What CI will going to do, as soon as you push your code, it will going to validate those. That, hey, if something is that, then yeah, let's verify checklist 1, checklist 2, checklist 3, checklist 4, and so on and so forth. Similarly, once it is being verified, it will going to push it. It will going to allow you to do the next phase, which is the deployment. It will going to create a compiled version. Let's say you have a code, and that code you want to be compiled with an exe or elf executable or macOS executable in case. So the CD will going to have its own, or you can deploy your own, of course. Con okay, sorry, there was some trouble from my end. I had to pause and let me resume. Yep. So continuous development is something which will going to create a compiled version for the different operating system, different architecture, and everything will going to be automatically. Some of the use cases that I have specified here, let's say a developer built a source code, it pushes the source code into GitHub repo. The repo has a test workflow design which will validate the source code for possible bugs. So let's say before you actually put it into a production environment or compile it with an exe, it will going to be verified. When there is no bug issue, it will compile the code and replace with the production system. So the CD is what being designed for that specific type of a thing. So what are the three major components that you should or you must be taking care of here? First, push and start an action. As soon as you push, basically you put any code into your GitHub, it will going to start a particular action. Action means validating of a source code and whatnot. I'm giving you an overall idea based on a developer and the actual use cases, which will eventually be replaced with a security workflows. So do not worry about it. Ability to do an action, for example, compile on a cloud-based system. So they have their own environment infrastructure in which they can create their own, let's say, executables based on the source code that you provide. So first is push and start action. As soon as you do something, it will going to start something. And what they can do is once that activity is being done, they can also have ability to uh, get some cloud-based system infrastructure in order to compile your code or execute certain code commands behalf of you, and ability to access production system for replacing the source code. Let's say the first stage, second stage, and third stage. Third stage, let's say your production system might not be hosted on the GitHub environment. That might be in your own environment, or that can be anything. So they have something called self-hosted runner, which you can put it on their side. I mean on the GitHub. If once you add your self-hosted runner or machine, then they will have privilege to access your machines as well in order to perform various things. Now, what are the things that we can achieve in terms of security here? Let's say you want to identify all the subdomains. For subdomains, let's say you want to executing you will be executing certain tools like sublister, AMAS, and whatnot. Now, what you can achieve based on this particular scenario, you can have a particular file containing the top level domain or apex domain list in your code base. And what it will gonna do, as soon as you pushes that specific file through the first component, what it will going to do is it will going to run particular task, and the task will going to be executing that specific tool from that specific thing. What do I mean by? So let's say you selected sublister. As soon as I add my apex domain list, it will going to send that list to the sublister as a tool, and it will going to execute that on the cloud environment of CICD itself. And once that specific thing is done, it will going to pushes back the updated data into the GitHub CICD itself. We will going to see this practically in a short time, so do not worry, do not get panic, and I'll explain everything. Moving towards the next, which is CICD component that you must be aware, or the component that are good for this specific talk. If you just have a quick go through the same. The first component is runners. What are the runners? Runners are basically the machines where the particular component or code will going to be executing. So let's say where your code will going to compile, or the subdomain sublister tool or a mass tool will going to be executed. It's a basically infrastructure where it will going to be running. Now there are two type of runner. First one is GitHub hosted. What the GitHub hosted are? So basically the machines which are owned by GitHub itself. and given to you for doing some sort of compilation process. Second one is self-hosted, the machines which you can add to the GitHub itself. And there are no limits for the self-hosted as per my knowledge or as per I have already attempted. If there is any, then yeah, you can just have a quick look. But you can add 10 machine, 12 machine, 15 machine, 18 machine, 20 machine, whatnot. So imagine you can use those machine within the CICD, within the GitHub itself, in order to achieve everything. The next component here are the secrets. Secrets are basically the storage to create sensitive variables. There are two part actually. First one is variables, second one is secrets. Variables are the one which you can use for defining certain values for a specific keywords, whereas secrets are the one which you want to be kept secret and not disclosing anywhere, no matter if it is log, no matter if it is whatnot. But yeah, it can be used similar to a variable, but a secret or sensitive one. Artifacts are the one which is component of GitHub CI/CD and might be for other CI/CD as well. Basically, once you're done with the particular activity, artifacts are the temporary storage which you can use in order to get a particular data out of that specific machine. So let's say I've used GitHub hosted machine. I have performed a mass activity, getting a subdomain, and I want that subdomain list to be uh, taken out of that specific job, specific workflow. Then you can use artifacts to get it out, and you can reference that artifacts to the other workflow in case you want to link each with other. The next component here are the matrices. Matrices are like a loop, and there are some limitations with that. 256 is what I can recollect right now. I might be wrong, but yeah, as far as I remember, it is 256 total parallel loop. So you can keep one matrix, and a particular task will going to be go through a loop. And how you can utilize it effectively? So let's say you have 10 different machines, or let's say you have 20 different machines hosted on the GitHub environment. It allows you to have unlimited actually. So what you can do is you can uh, split your Apex domain file with 256 lines, and you can give it to the specific tool. So at the same time, it will going to use whatnot number of GitHub hosted machines or self-hosted machine in order to execute all those commands parallelly. That's something which I'll keep on you for explore, because I don't want to give you so much headache here. But yeah, metrics are the thing which will going to repetitively doing a certain task. And there are some limits of 256 that you need to keep in mind. Jobs are another component which is basically action or a task for a single machine. So let's say if you have created a particular job, everything inside that specific job, or let's say executing one command, executing another command, executing third command, everything will going to be used for within a single machine. And you can have multiple jobs, of course. There are no limits as such. Let's take one practical demonstration for the CI/CD, and it gives you the whole overall idea about the different things that we have already seen or looked into. So what I've done, I'll just going to create one repository with the name of Mysticon 2024. Whatever the description you want, I'll just create with the private specific, because I don't want this to be exposed over internet. Of course, why I should put my data over internet? Then I'll go with the action. Yeah, it's pre-recorded, so yeah, you'll get some delays. I'll just add new self-hosted runner, and you can choose whichever you want, if it is Mac OS, Linux, or Windows. I'll go with the Linux specific because that's the only thing I'll require for this specific talk, but you feel free to add the other one. So what I'll do, I'll just follow the path. Those are the basic commands, nothing fancy. First is creating new directory, cd into it, calling that specific component, specific runner version basically, and giving an unarchive or unzipping that specific unzip file. And once you're done with that, all you need to do is configure. Here we go. And of course, the config.sh doesn't allow you to configure with the root access. So what you should do is you should modify it. Basically, there's only a single check. What it does is it will going to get check if it is running through sudo or not. Let me just open it. I had to pause for certain things. Here's what other things I need to do. What I did, if user ID is not equals to 0, I just replace that with 1. That's it. Usually root are the administrative user, right? Or with the 0 UID. I'll go with everything default just by pressing enter, enter, enter. If you wish to give a specific name, then yeah, you can specify here. If you want to give a specific label for that specific runner, then it allows you to. The label can be used if in case you want to run specific task on a specific machine. So let's say you have certain machine just for a compilation process, certain machine just for execution process, certain machine just for a specific task, so you can have that type of a thing. I'll use svc.sh in order to install a particular service, and you can use 0 as a UID to install a service with running with the root user. And you can also start by just using svc.sh. Yeah, not the run, it's the start. My bad. Here we go. Now the service is running. I'm expecting this to be visual over the self-hosted runner. So what I'll do, I'll click on runner one more time, and here we go. It is idle. Idle means basically it does not have anything to be work on. The next thing, I'll just try to create a basic action or a workflow. All you need to do is go to action. There are some pre-configured action available for you just in case you want to explore. But for a security perspective, we do not really need that. I'll go with the simple workflow, just give you a quick overview of everything. Here on is the thing which you can use for scheduling, or it is a component which will going to tell when a particular workflow will going to be executing. Currently I'm using workflow dispatch. Sorry, I have to stop. Yeah, here I'll just replace certain things with the different. Here what it's gonna do, run who am I is what the job name itself. Runs on Ubuntu latest will going to use the GitHub hosted runner, and self-hosted will going to use the runner which we have just installed. The first one, it says check out the code. Basically those are let me explain those in a little detail. Let me pause it for a moment. Actions slash checkout at v4. So there are some pre-configured actions available within the GitHub repository itself, which can be used by anyone in order to achieve some basic things. You can create your own actions as well. Basically it's kind of a workflow which you can define, and that will going to be performed by on that specific machine. So this specific action, GitHub checkout, will going to check out the code for the specific repository. Checkout means it will going to pull the code with, let's say, git clone kind of a thing. And yeah, that's what the checkout is doing. The second one, run who am I, is what the name for that specific task. And what it's gonna do, it will run who am I, put the data into whatever the file you want. Let's say I want to put it on the readme file. Here, those are the default one. I'm just replacing it with the one that I would like to. So let me just copy and paste it from my code base. copy the command instead. Okay, when I added here a pipe, that means I want to execute multi-line script. In case you are not aware, I'll just give you a quick view. What we're gonna do, it will going to add a readme file as an upgrade. It will going to give a commit as readme updated or whatever you want to be specified here. It's just a value that you want to notify that okay, what exactly things are done here. With the git push, it's supposed to be pushing that specific thing. So I'll give you a quick view. First, the name of that specific workflow, it is basic one. When it will going to be executed, it will only execute with the workflow dispatch. Dispatch means if someone executed by just clicking on that run workflow, it will execute. There are some other triggers like on specific time, on specific date, on specific file update, file push, that we will going to look further in the upcoming slides. Then the jobs are basically, each job will going to use a single machine for any number of steps in which. So first, there is only one job here with the name of run who am I, and in which it will going to run on a self-hosted. Runs on self-hosted means the runner that we have already added. Second steps would be action checkout. First one or the first execution would be getting the code pulled, then running a particular command, putting into the readme file, pushes the code. That's it. There are some challenges, it's not done yet, which you might also face, and I don't want you to be as such. So I'll just give you a heads up. So let's save it. Let's try to run it quickly. You can click on that view runs or go to actions, and both will going to achieve the same. Either you can click view runs or directly go to the action. I'll run the workflow. Let's run it. It's supposed to be failing, which I'm already aware, and this is something good for your learning journey. So-called issues that you might face and what are the solution in which. We go, it's already been running. Let's navigate. The setup job will going to do the setup things, means for running this entire code base. Run checkout will going to clone it. Run whoami will going to execute that command, on which push the code is where I'm getting an error. What it says, please tell who you are. Of course, we haven't specified by default. Let me pause it for a moment. I'll give you a broader view on this. By default, GitHub also has a particular temporary, I would say, token, which can be used for doing pull and push activity. But that code or that specific, let's say, that specific token require you to specify who you are, what's your email and what's your name. If you don't specify that, it will going to be failure. There might be some other workaround that you can explore, but this is what I have already encountered and found a solution for. So let's try to fix this specific thing by just modifying the actual workflow file. So what I'll do, I'll navigate to my settings. I'll go to secrets and variables. Within the actions, there are two components here. First one are the secrets, second ones are the variable. This is what I have already explained. Both are type variables. Secrets are the hidden variable, something like your password thing, and variables are the one which is just a variable where anyone will able to see what is the content of it, like that. So let's try to create one variable first. I'll give a variable name as, let's say, username. Whatever my username, currently it's Robensiv. I'll specify my Robensiv as a value for that username so that I can reference. This way I no need to specify again and again and again and again for every workflow. I have created one variable, that variable can be reused. Second one, I have already created a secret for user email. in which I don't want my email to be exposed over the internet, let's say, over for anyone. I can create one repository secret as user email, and that can be retrieved. That can be used within the same. So there are two things: secrets, user email, and the variable username, which is something I'll going to replace. I'll going to reference, right? Secrets value will not going to be disclosed, but variables would be. Let's try to specify those things. Get config hyphen global user dot. Let's go with the name first. Let's go with the email. The email, what I'll do, I'll specify my variable. There is a way to specify your variables here, or secrets and variables both, by just using curly braces before with the dollar. So dollar twice curly braces, in which you can specify whether it is secrets or a variable. For secrets, it will going to be secrets dot user email, whatever the name you have specified for your secret. And for user, which is of course a variable, you need to replace that secret with vars, vars, vars. That's pretty much it. Of course, I need to change the name of file of that very specific component as username. That's perfect. Let's try to save it and run it. In case you want to give a little bit of information what exactly you did, let's go with the vruns and run it again. Those are the challenges I want you to be aware, and that's the reason I've included here. First, we're going to check out run whoami, and push code has again an issue. What it says, write access to the repository are not granted. Of course, by default, the repository you can pull but not push. In order to have that push thing, you need I'm sorry, you need to define a particular permission. Let's try to allocate that specific permission. Looks like in the video I'm going quite slow. I'll navigate to my settings. I'll go with the actions, and let's specify the permission right there. It says read and write permission. So I'll just going to give the read write permission, and that's supposed to be fine. And in safer side, I've added another permission, but that shouldn't be a blocker. All we need to do are the done thing. So now let's give it a shot. Shouldn't take much time, and I should be able to see the result back. Be done. Okay, yeah, that worked. That perfectly worked. And if you see the push code, it successfully managed to change the code itself. Now there is a readme file with the context of who am I. So whatever the result of that who am I is being pushed to that specific readme file. This was overall for your learning, for your understanding and whatnot, and gives you the overall information about everything. Let's try to change the self-hosted this time with Ubuntu latest, which means there are some there are some, let's say, GitHub hosted runner, and you can specify which runner you want to use. Ubuntu latest is the one which will going to use Ubuntu latest operating system based GitHub hosted runner or GitHub hosted machine. in order to execute our code. Of course, the result will going to be same, no difference. It will also be running on the root user. So expect you to have that root account here as well. Let's give it a shot just to give you an overall idea. I haven't used my self-hosted machine. I've used Ubuntu. For my self-hosted machine, it's not the same version, but yeah, here I've used Ubuntu, which is hosted over the GitHub, and the operating system version, which should be visible on the top. Things are fine. The job is entirely completed, and the version supposed to be in that first column. Here we go. It's Ubuntu 2022.045 LTS. Whatever the version, latest version, which is over the GitHub hosted, it will gonna be visible. Now here, the runtime. This is a very important thing, and you must be aware that runtime is what you will get free from the GitHub. In case you have a free account, then it will gonna be 2000 minutes somewhere, minutes or seconds. I'm not 100% sure, but 2000 is what you will get a count for it, and this is where it can be utilized. So by 2000 means it will going to be 2000 seconds. Let me just quick check, just on a safer side. I don't want to be false here. uh, GitHub posted runner time limit. Of course, it's on my different screen. You won't able to see it. Usage limits and billings. Still looking into about GitHub posted runners. Um, Supposed to be 2000 seconds. Checking. Okay, it's a 2000 minutes, which means a lot, a lot. All right, I had to stop, but yeah, I had to pause, not to stop, of course. So here it utilized 2 seconds of time, and we have 2000 minutes total for every month. So imagine how many things you can achieve with that specific thing. Let's move further with the other thing. And yeah, by default, you get 2000 minutes, what I have cross checked. Oh, okay. I didn't know that. I already had it in my in my video. So yeah, here it gives you the information that per month you will get 2000 minutes and the storage of 500 MB, which you can redeem. That's the whole in short about the CICD and a demo for it. Even if you have a pro version, you don't get much difference. So yeah, free version would be sufficient for a learning journey. Moving towards the next slide, which is yours. Oops. Wrong. Yeah. Attack surface management. What do you understand? What do you know about attack surface management? I'll just give you an overall broader view for the specific thing. Attack surface, basically an organization have different possible attack endpoints. There could be from external, that could be from internal, from physical, from whatnot, right? And everything considering a specific organization, those endpoints which can be attacked are considered as attack surface management, or the information about the entities which can be attacked are known as attack surface management. That's the whole and short information that I can give you. For an example, here I've given a particular picture that, okay, what are the things which can be achieved in order to get inside this house. What are the component used by an organization? Let's say there are some CCTV cameras, there are some locks, there are some smart systems, uh, someone sitting on one phase where another one is not. What are the components which are working during the night time? What are the components working with the daytime? So on and so forth. That's just an overall information about it. Of course, this is what AI generated. I haven't created on my own, but yeah, just give you a broader idea about the same. Everything which is related to everything or in terms of information, every information for an organization entry points is what we can say as a attack surface management. What I think of, let's say, give you some more example. A particular organization uses thousands of domains, top level domains or apex domain. That is what we can say a part of attack surface management for an organization, which can be attacked by a particular hacker, attacker, or threat actor. Another thing, the exposed IP address, a laptop which they already give to their employees, or the network shares, whatnot. There could be n number of things which we will going to learn just up next slide. There are two components basically within even the attack surface management. First one is external, second one is internal, but there is no first and second as such. But yeah, there are two components. First, which is external, means everything related to externally exposed assets. This can be also include the public IP address which they own, the domain, top level domain, apex domain, subdomain of those domains which are exposed over internet. Usually those are external vulnerabilities. Of course, that does not mean just only assets. The vulnerability residing on those assets would be also part of attack surface management. Public repository, even if the organization uses GitHub, they create, let's say, by somehow for some reason they created a public repository hosting their sensitive information, secrets, whatnot, is also part of and their attack surface management. Cloud services, if they are using AWS, Azure, and whatnot over internet. Remote access point, if there is any VPN which they have exposed over internet that can allow an attacker, threat actor to get inside that organization. Mobile apps, IoT devices, and etc. So basically any assets or vulnerabilities that could be attacked from the external perspective are considered to be external attack surface management list. With the internal term, it means everything which is only accessible for internet, like servers, that could be web application servers, internal application server, database server, file server, SCCM server, and whatnot. Workstation, the users or employees laptop, desktop, mobile devices, or IoT devices which are being used by the organization itself. Network infrastructure, router switches, IDS, IPS, firewalls, VPN gateways, whatnot, internal crowd services if they are already using, etc. Everything which is only accessible from internal or an internal attacker can achieve is what considered to be internal attack surface management. A management of the different attack surface is overall, I can say, an umbrella which is called as ASM. So remember, two component, external and internal, for the attack surface management. And using CICD, we can actually narrow down everything to automate. We can even do certain internal based testing. We can also do external based testing with just help of CICD. All we need to do is create some automation workflow. You can use AI, GPT, whatnot in order to get some references, ideas, and so-called things, and you can just deploy it. So next time when you do want to achieve that thing, it will be easier for you. Let's take some external attack surface management into a consideration with the practical manner. Due to the time string, I have just kept everything as short as possible. Now I'll not gonna go by starting writing everything and doing things. I'll just start with the predefined, pre-created workflow for the same. So here, very basic workflow it is. What it is doing, it is reverse who is workflow, which is defined what it's gonna do, it will take input ips.txt, and input ip.txt will going to have a list of IP address. So let's pause it for a moment to give you some overall idea. Let's consider that you are working for a consulting company, and you got a target that you need to scan those external IPs. Then what are the different scan engines you will gonna use? Every time you will going to perform it through various tools manually, but you can actually create a workflow. So next time when you have a different client, it will be easier, right? Similarly, let's say you are working for a single not a consulting, for a single organization, and you are just working for something like a purple teaming. Then you can define your own workflow dedicated for that organization, and all you need to do is run it one more time whenever they ask you to redo the same type of assessment. Let's say they want to know what are the exposed IP address over internet that belongs to my organization, your organization, whatnot, and that can be automated. I'm just giving you a broader picture of how useful and fruitful this could be. That's being said, what it is doing, it will going to run on Ubuntu latest, because those are externally hosted. For external something, will not gonna worry about accessibility. What we're gonna do, it will going to first check out the repository. Sorry, there was some issue. Let me move it ahead. Da, 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 da. Come on. Yeah, that's supposed to be fair point. Here, what we're gonna do, it will going to check out the code. It will going to install the Golang. Why I'm using Golang? Of course, to advertise my tool, which is Task Ninja. And there are some pre-created workflows, and you can use Task Ninja along with CICD in order to achieve something uh, very easy to manage thing like that. So Task Ninja will going to split your task into so damn good fast speed capability, and it's kind of a it's kind of a framework that you can use. So then it will going to install Task Ninja. What Task Ninja? Everything I've already defined in this. It's recently updated, not so long. So I'm actively trying to update. I'll just check the version, which version you want for the Task Ninja, and based on what you can install that specific version. Whatever the tool you want, you can just specify this. Of course, this is another action which I've already explained earlier. This action will going to do setup go, basically install Golang for you, and based on the version that you define. Then it will going to install Task Ninja, run that specific tool, which is Task Ninja, with the whatever the argument it requires. So right now I'm giving a no banner, which is nb-w is based on the workflow name you want to supply, and the workflows are saved inside workflow slash whatever the workflow name it is. Hyphen detail will going to give you a detailed output and not the lesser one. So let me what's wrong? Come on. Yeah, looks like I've just pressed something wrong. Yeah, moving towards the workflow. What exactly inside that ipwhois.yaml? So basically that ipwhois.yaml is a workflow created for Task Ninja. The use case is pretty simple. You need to provide a list. I have already hard coded that list here, which is input slash ips.txt. So you can, if you don't want that to be here, you can just place it somewhere inside your code base or the GitHub workflow. This is Task Ninja workflow, not the GitHub workflow, remember. And if you want to explore further for the Task Ninja, navigate to that Task Ninja GitHub repo. There are 2 videos dedicatedly created to give you an overall idea. The task for the Task Ninja is a dynamic, means it will going to loop through every lines of the file specified. So here I've specified file which is input slash ips.txt. It will loop through it, and based on number of thread, it will going to run parallel container. Here there are 10 containers will going to be running parallel. It will just supply, let's say, it will just going to pass on hyphen h with the particular reverse Swiss, let's say, side, which allows you to give you that information, and hyphen v will going to be a value for an IP address which you want to supply. So let's say if we have 127.0.0.1, it will going to be replaced with this dynamic file. So each line will going to be replaced here. and the output will going to be saved inside default hive out and output.txt. The next what it's going to do, it will going to get all the output here and put it into a single file. Basically here 10 different IP address would be there inside the ips.txt. Basically there are 10 IP address parallel. It will going to run 10 different docker containers, and whatever the output, it will going to be merged in the result workflow or a result task. Inside the workflow I call it as task. So that's being said, let's give a short look further. It will going to run the task ninja. It will going to copy that result. So basically by default, task ninja uses hive as a default shared location across. So hive result out output.txt is what does contain all the output, all the, let's say, merged output. It will going to put it inside result slash ipwhiz.txt. The next, it will going to upload it here, upload it with upload artifact action. As I mentioned earlier, actions are the one which allows you to have certain activities to be predefined, and then it will going to push the same way that we have already seen earlier. So what I'll do, let's try to execute. I've already executed actually, just to save our own time. Let's have a quick look. So first, setting up a job means getting all the required things, components and whatnot, permission things. Checking out the repository will going to clone the repository. Installing Go will going to install the Golang version. Install Task Ninja will going to install Task Ninja in that specific operating system. Run Task Ninja will going to run that specific tool, and whatever the output as I have specified detail, it give you the whole information. Parallelly, what it did was it ran all 10 tasks together. If there are 20, then of course first it will start with first 10 and then it will move towards the next 10, and the whole output is being saved with this path, as you see, hive slash result out output.txt. And let's move further with the copy result. It will going to copy that specific hive result out output.txt into results and output.txt. Of course, I'm creating one directory here with the results name so that it can be saved, and then it uploads those artifacts, pushes results towards the GitHub, and that's all. That's pretty much straightforward. Then yeah, okay, I've executed whatever the result I want to be posted over GitHub so that I can either get it downloaded, or I can even get it from the artifacts. Yeah, artifacts are the one which I mentioned, temporary storage, whereas repository storage are different. When you use upload artifacts, it will use those temporary storage which has probably 30 days of time frame for deletion. You can come back to this workflow and click on that to download, or else you can put it inside the GitHub repository itself. So you'll see that result contains iphost.txt, and it has all the information. Let's say the AS number, IP address, BGP prefix, CC registry allocated, and whatnot. The, of course, organization name. And based on what you can identify what are the component from my organization and what are not. Looks like I have to move back to that slide. Something went wrong. Supposed to be here. And that's the whole and short information that I would like to give you here based on discover and scan public IP. You can also scan it further, so you can take out this IP address component. You can scan it with various tools and map whatnot. You can filter out those results based on, let's say, your organization. You're working for, let's say, Tesla. You can search for the Tesla itself, and if you find Tesla, then yeah, you can mark it for you. Mark it. It's not market. So yeah, just a quick pronunciation fix. That's being said, let's move towards another workflow that I have created. Remember, I have done a lot work here, but everything I cannot include here. I want you to explore it further. I'm just giving you an overall idea for such tasks. So the second workflow here are related to subdomain discovery. What you're gonna do, of course, the job name it will going to be run on a Ubuntu latest, means GitHub hosted. I no need to worry about my own my own infrastructure. Everything will be managed by GitHub itself, because those are the external. When it comes to external, I won't be caring about from which machine I'll try to scan, which machine I'll try to perform certain action. But when it comes to internal, I have to be very careful, because it's supposed to be accessible, right? So yeah, it will install that Golang. It will install the Task Ninja tool. The Task Ninja through the Task Ninja tool, it will going to run passive subdomains.yaml workflow. What this passive subdomains.yaml workflow will gonna doing? Of course, it will going to scan the passive It will going to get the subdomains from the passive engine. I'll give you a quick information about passive. Passive are the one means I'll going to query certain let's say subdomains to a particular service, which will not going to inform the actual owner that yeah, those specific guys try to check for subdomains from you. Means the owner will not going to be acknowledged when we do the active one. They will going to get to know that someone tried to query subdomains for that specific uh, top level domain, because they will actively get a log. But when it comes to passive, we will try to do scanning or identifying or discovering through different service owners, different services, or let's say other websites, not the actual domain itself, which can be false, which can be right. We never know. Moving further, let's see what are the component for the passive subdomains. Here, first, it has the input list, which is apex.txt, and currently apex.txt has only one single top level domain name. You can have multiple, of course, that will not gonna be a blocker. This specific workflow is also found on my external repository, which is Task Ninja workflow. First, it will going to get it from GIDC subdomain, one of the Docker container I've created for it. Subdomain center is another site from where we can get the free asset finder, find domain, Vita subdomain, and subfinder. There are some more which are, let's say, kind of a paid, not paid actually, but that requires a license key, or that requires authentication kind of a thing. Like a chaos and GitHub subdomain. GitHub subdomains require you to provide the GitHub username and password, and chaos require chaos API key. So if you have that, you can just uncomment that out, and it's supposed to be fine. You can also specify those keys over the variables list. Here it will going to merge everything. Just remember to uncomment those tools in case you want to achieve it. And then the result will going to be having everything saved inside output.txt. Let's see how the actual it worked for us. So let's validate. Same as other, installing Go, installing Task Ninja, running a particular Task Ninja workflow. And this workflow will going to first pull out all the images required. Then it will going to start. Yeah, pull out all the images required, and it will going to start. Oops, what's wrong? Ah, okay. Looks like I pressed somewhere. Yeah. Here, with the start, it will going to first go with the GIDC and so on and so forth. Lastly, it will going to go to get the result saved inside hive result output.txt. The copy result will going to copy the result into desired location, and upload tool output will going to upload it to the artifacts. Artifacts are the temporary storage, whereas when you push it, it will going to be permanent into your code base in your repository itself. So let's see what are the results saved by that specific workflow. Navigating by results, passive subdomains.txt, and here we go. We have a lot subdomains identified with just a passive things, no active things at all. There are almost 1200 somewhat, as I remember. Let's scroll down. Let's wait for the scroll down. Of course, those are the videos. 1273. That's a huge number, right? And we have 1273 number from a single domain. So magic. I hope that you get an overall idea how you can and what you can achieve from this specific thing. Now, Task Ninja also have this specific workflow exposed. So in case you would like to give it a try, just navigate to Task Ninja hyphen workflow. And here we go. Workflows, not workflow. Here you'll find in the discovery, go for the subdomains. And inside subdomains, there it is one cert asset subdomain and another one is passive subdomains. With the passive, you will find this exact workflow as it is. There might be some changes with the result tab or the last part of it, but those are the minor changes with the file name. Let's say instead of result.txt, it will going to be output.txt, like that. When you do give it a try, you'll get to know about this. But yeah, I just wanted to highlight it quickly. That's something for the subdomain. Let's try to move further. What else? Let's say we identified IP address, we found a particular domain was a targeted. We tried to perform subdomain discovery. Now we will going to find the web application. Of course, you can find other things. You can do nmap scan. You can do n number of scan. That's not a blocker at all. Here what I'm doing, I'm just exploring the web application. What are the web application out of it? What it does everything similar. The name of the workflow, it will going to get the result. Remember here, whenever something pushes to this passive subdomains, you can have a different name. Let's say a merged domain or something from active as well as passive, and that file can be used to check. So someone pushes into this specific thing, a specific file, then it will going to be automatically triggered. Then it will going to do a workflow dispatch. It will going to use Ubuntu latest. Workflow dispatch means basically you have option to run this specific workflow manually without any trigger. So yeah, checking out the repository, installing Golang, installing the Task Ninja, and once Task Ninja is installed, you need to run that specific workflow. Nothing different, only few lines might be changed, and that's all. Copying results, uploading artifacts, pushing the code. Let's see what are the web discovery component. Here, of course, this is Task Ninja workflow. This workflow is also exposed over internet. It will use a specific list which I hard coded. It will use this specific user agent. I've excluded some of the ports from the actual one because it was taking too much time for me for those 1200 subdomains. So I removed it. I just kept 80 and 443, but feel free to add in case you want to explore. DSL is, to be honest, very amazing component which are provided by every project discovery tool. Every project discovery tool has this DSL query, which can be used to remove, filter, or add a specific specific type of result. So let's say what I'm checking here. If body contain purchase this domain is for sale, buy this domain type of a result, then just exclude it. Of course, it was not required for the specific task. I just gave you for a quick overview that in case if you find something, just exclude. I don't want that to be included at all. It will going to run HTTPX, and I'm using the official image from HTTPX. It uses dynamic execution, means parallelly 10 thread. So 10 Docker container will going to be running. So at the same time, 10 subdomains will going to be scanned through this automation. Timeout will be 10-second. Port are the defined port which are specified. It will retry for it twice. It will be silent with no color and using this specific DSL. The output will going to be saved inside default hive out and output.txt. Next, it will going to merge every result into a unique output file. Let's see how it did in the actual execution. Web app discovery. Let's try to see the result. Of course, artifacts also has that result as well as the GitHub repository. Artifacts are the temporary storage which will going to be removed. It took almost 33 minutes, 14 seconds for this specific task because they were huge list, honestly, quite huge. Let's see what are the results for the web app. Doo-doo-doo-doo. There are almost 524 number of websites identified from that 1200 subdomains, identified subdomains. I hope that this gives you an overall information about what are the things you can achieve in terms of external. But this doesn't limit you only for external. You can do the internal attack surface management as well. So let's say you have a role of something that you need to identify all the network shares, or you need to do iPort scan, you need to do certain things. All you need to do is create a workflow, add your machine through which you will going to perform those activity to that specific repository, create those workflow and run those workflow. And the next time if they ask you, all you need to do is click on that run button and it will be automatically achieved. Or for the next organization as well, if you want to do, all you need to do is copy the code, put it into new repository, add a new runner and run that activity. This will save a lot time of you, a lot to be honest. Here I've created one of the workflow which is for the port scanning itself, and that will used for scanning a particular services. Along with, I'm also kind of not a parsing, yeah, kind of a parsing the results with another workflow which you'll see right here, which says nmap parser, that I'll gonna explain in a bit. So let's move further. The name itself is port nmap port scanner. It will going to use internal ips.txt, of course. Those ips, internal ips. This specific IP address is something for in my own local environment, and it uses this self-hosted, means the machine which I've used for adding it. I've used that basically. It will first going to do the checkout code, performing nmap through the Task Ninja. Here I haven't installed Task Ninja because it was already installed. As I have checked out the code, every code data would be there. So workflow portscanner.yaml would be also part of it. It will going to copy the result, to, let's say, a specific file path, which is result/nmap, upload it as an artifact in case you want to get a one-click saved button thing. Let's say you want to get it downloaded locally, and that's it. Let's have a quick look for the action, how the nmap port scanner worked. Here, it's pretty straightforward. Only one IP was there. It didn't took much time, and yeah, for self-hosted you don't have time limits here. But there is a time limits of 6 hours for each task. So if you believe that your task will going to take more than 6 hours, then just avoid. Try to avoid as avoid means try not to include it, or try to split the load. Use the matrix, use the other component, but not use a specific job to be taking 6 hours, because there is a limit from GitHub itself that you cannot add more than 6 hours. And you need to remember this. Here with the result, if I navigate to nmap, out, xml, gnmap, and nmap based output are there. Now XML are the easier for parsing, and for that I'm using another workflow, which is nmap parser, which will going to take those XML. If something modified in that XML folder, it will going to perform this the same activity, nothing difference, running, installing, and nmap parser workflow is there, which is also exposed, which I have already publicly released. Then if you don't find, then just do reach out to me, I'll give you a link for it. It will going to upload, push, and the commit always changes, remember. Now let's see how it worked. Here it is, what the result for it: IP address, state, port, and whatnot. So similar kind of you can create your own Python script, you can create your own bash script, you can create your own tooling and put it over the GitHub. Just have it somewhere in the code base and run it across, and when as soon as you run it, you will get your execution through cd, continuous deployment, of part of the GitHub itself. I hope that this gives you the overall information about how and what can be achieved. Of course, we have less time in which we cannot have everything mentioned here, right? So for internal, I've just limited with just a port scan and making it a beautified version of it. Moving towards the next, what else you can do achieve from this specific thing? Malware development is number one thing that I'm planning for my future use cases here. So let's say you have GitHub hosted containers that also include some of the compilers. What all you need to do is put your shell code into a specific path, and based on your shell code, it will automatically compile it with the various executable format, let's say exe, elf, macro, and whatnot. It cannot automatically sign your code if you have something like a leaked signer, leaked sign, or I can say leaked certificate. Then you can sign your Trojan with that certificate. If you have something like a cloning kind of a sign thing, then yeah, you can also use that. You can obfuscate your code. You can convert your malware. Let's say you have your mimikatz, you want to obfuscate your mimikatz. You have a PowerShell script, you want to obfuscate that PowerShell script, but you don't want to do it manually every time. You can have those workflows. You can have those uh, GitHub services to be used in order to achieve that type of thing. Another thing, APK analysis. APK analysis, let's say static analysis, you always maybe trying to do a decompilation, getting finding for some things, identifying, getting and whatnot. So everything can be achieved with that. All you need to do, upload your apk in a specific drive. As soon as the directory has the particular changes, what it will want to do, it will run those parallel container, parallel execution, and it will going to achieve it. Vulnerability discovery is one of the best. SAST is what it is designed for, of course. Means if as soon as you push your code changes, it will going to do verification if there is any sensitive files, sensitive directories, sensitive keywords, or something like that. Or else if there is any vulnerability, you can create your own. Let's say you want to identify if there is any XSS vulnerability in the whole application. What you need to do is put the source code in the zip file, and you can create a workflow. It will going to unzip, it will going to perform certain tasks, it will going to identify, get the result out, and that's it. All you need to do is convert your SATS tool into Docker, or it can be also without Docker. So it is not limiting it with the Docker. So you can use without Docker as well. Red team out, dast as well. Before red team, let's say dast. So with the dast specific thing, I've used zap in my last quarter, I would say. So I was doing in that case, the zap allows you to run within the docker, and you can create some kind of a workflow for the zap in order to do certain automation. So what I was doing with the GitHub CICD, as soon as I get some list of let's say path from from whatnot, let's say from manual actively discovering through Katana, or passively discovering all the URLs uh, from from the Wayback Machine. I was just having those lists passed to that Zap configuration file automatically through CI/CD, and another CI/CD was doing that Zap thing. So Zap was entirely converted over the CI/CD, and it was doing the active phase. You need to be very careful about that 6 hour time frame. So if in case you have a huge list to be scanned, try to minimalize, or try to use the zap workflow in a way that it shouldn't increases the time frame for you. So keep it minimal as possible, shorter. You can have multiple jobs, so you can have matrix as well. In case you found that okay, 6 hours is not enough, try to split your role. As soon as you split, it should work. So you can have n number of splitted tasks. Red team automation, running various enumeration tool, ping castle, sharphound. So let's say for an engagement, I want to run certain tools over on a particular environment. So what I can do is I can have just my GitHub runner host executed on that specific machine. And that GitHub runner, through the GitHub runner, I can execute those tools like Pincastle, Sharpound, and whatnot. Of course, those tools can be quite obfuscative through another techniques, which can be obfuscation or encryption and whatnot. So everything that you can think of doing an automation and requires an environment, of course, you can do it. So GitHub CI/CD is the best across automation that you can choose for, and it's free. Of course, 2000 minute for free is quite huge time, to be honest. Even if you out of that time, you can use your self-hosted runner, you can use your own machine, your own environment, in order to achieve it. What else you can do is, of course, password brute forcing. You can have created a workflow which will going to brute force your passwords. All you need to do is add your hashes files into that repository, it will crack it. And you can use your that cracking machine, you can keep it anywhere, you can keep it in your local environment. Even with the low internet speed, it shouldn't be a blocker, because it uses a push method, push and pull method in terms of communication. So you won't be having that type of thing. But yeah, you can achieve a lot. You need to be careful about you only need to be careful about that 6 hours time frame and some other things which are minor. But that's it. That's all what I thought for this specific talk. Hope you enjoyed. Hope you learned multiple things. And if you do, yeah, thanks, ninjas. Ninjas is what I called when someone try to automate and not doing everything manually. Try to automate everything as possible so that you can work on the actual thing, which is researching or improvise yourself. Doing same thing again and again and again will not going to be an improvisation for you. If you are doing something similar again and again, try to make a way to automate that so that you can utilize the other time frame for yourself. And if you like the idea, yeah, you can follow me on those as well. Over the YouTube, I try to create some good, fruitful, insightful content. Over Gitbook, I have created one of the codes for OSCP. I had to stop for some reason, but yeah, I'll resume it as soon as I get some time. I do have community for over the Telegram that you can join, where you'll get some newses, some tools, some courses, and whatnot. You will get some insightful information. So that's it. That's all. And again, once again, I would say, uh, thank you so much, Visarian, for having me here. That's it. That's all. See you next time.